Today we're going to be looking at integrals of trig functions, and we've done a couple of these already, and we're actually going to figure out these three basic trig function integrals right here. And so we're going to actually prove what these are, and then after we do that, then we'll just be able to use the integrals that are down here in this box. But let's prove it because it makes us feel smart.
Yeah.
So the first one is just the integral of tangent x dx. So in trying to solve this, the first thing I'm going to do is rewrite tangent x as sine over cosine. And if I were to give you this problem here, you could probably find the integral using the natural log, like we were doing last time. So if you'll notice here, cosine x, we could let that be our u. Okay, and then the derivative of u, derivative of cosine is? Negative sine x, good. And so at this point, we can see that we almost have u prime over u, almost. All we're missing is the negative. So that's what we're going to do right here. We're going to put this negative here, and if we put the negative inside, we're going to put the negative outside as well. So now you can see that we have negative integral of u prime over u. Oops, that's everything. Okay, and if we were just going to find the integral of u prime over u, what is that? Okay, so it's negative natural log of absolute value of u plus c, right? And then we're just going to substitute u back in here. So this is negative natural log of the absolute value of cosine x plus c. It almost seems fake, huh? So, because we have the natural log, now we can find the integral of the tangent function, which is very exciting. Okay, and so you can see that one right down here listed for us. Let's go ahead and try the same type of process now, but with the cotangent function. So the integral of cotangent, if we were to use the same type of process, how do you think we might want to write cotangent? Cosine over sine, good. And what should we let u equal? Sine x. And then du is cosine x. Okay, cosine x dx there. And so if we're looking at this and we want to use U-substitution, do we need to alter anything? No, we already have u prime over u. Okay, so we can go ahead and just do the U-substitution here, and we get the natural log of the absolute value of sine x plus c.
No, I was nothing.
And you can see that that's right down here. Integral of cotangent u is natural log of sine u. And there we go. Now this next one is pretty tricky. And you might not be able to just stumble upon this on your own. So we're just going to make a change here. So we're still going to have the integral of secant x. And we're going to multiply by 1. But watch what we do. This is kind of crazy. We're going to multiply by secant x plus tan x over, so we want to multiply by 1, so secant x plus tan x. Okay. The point will become clear.
It makes it more complicated. Just for kids.
Okay. So let's go ahead and distribute the secant x in. Okay. So we have the integral of secant squared x.
Wait, was there anything over to the right after the parentheses?
Oh, it's just dx.
Secants and the tans cancel out.
Okay. So plus secant tan over secant x plus tan x. Okay. Now, the reason we did this is so that we could let u equal secant x plus tan x. Okay, so we're going to let the denominator be u, basically what we've been doing. And what is our derivative of secant plus tan? Well, we know we can take the derivative of each function separately. So what's the derivative of secant? Oh, not quite. Secant squared. So derivative we're thinking now. And those are just kind of hard to keep memorized. Mm-hmm. Oh wait, no it's not. It is secant x tangent. Sorry about that. Nice call. Okay. So the derivative of secant is secant x tangent x. And then the derivative of tangent is secant squared. Okay, there we go. Okay. And now, if we look at our integral, what form are we in?
Say du over u.
Du over u. Okay. So, if we're in du over u, then all we have to do is take the natural log of u, which is secant x plus tangent x, and then plus c. All right.
How is it that it works on trig functions since they are repetitive, wavy, up and down, and cancel themselves out?
It just works out because a lot of trig functions are written as fractions. And so, and the fact that they're derivatives of each other sometimes, meaning you can use natural log function to do it. Just like 1 over x and natural log kind of go hand in hand. All right, so here are your integrals of your 6 basic trig functions that you're going to want to also memorize. Okay? So a couple of them are from before, like sine and cosine we already knew. Okay. And then these are our new ones here for today.
We just didn't prove the cosecant.
We didn't prove cosecant.
We don't know how. We don't know how.
We don't need to.
Okay.
It would be similar. It would be similar to what we did with secant. It's just 1 over, and so then it's just flipped around.
What do we have to have in the class not take this final? Is it 85 or are you one of the
Not
teachers
pertinent
who
to the
likes
lesson that we're recording valuable time on,
Well,
but
I'm just curious.
it's an 85 or better to not take the final. So let's go ahead and do some of these examples, shall we?
My head is thinking about something I don't want to take it.
So we have the integral of tangent 2x. Now, to be able to do this, if it was just tan x, we'd be fine. But because we have tangent of 2x, we're just going to change u equals 2x and du equals 2. Okay, so we're still looking at this right here. And notice in our function it is tangent of u. So u equals 2x, du equals 2. What that means to me is I need to rewrite this integral to be 2 tangent 2x dx.
Don't you put a half on the outside?
So I put a half on the outside. Very good. So now this is in the form of tan u du. Okay, and from here, now we can use our integral of the basic trig function. So we know it's going to be negative 1/2 times the natural log of tan u plus c. And then we just substitute in for u. So the negative right here.
So then it's not cosine.
Wouldn't it be
Wait,
cosine?
yeah.
Is it?
Oh, it would be cosine u.
So negative 1/2 natural log of cosine 2x.
Yep.
So like once you get in that form, then you can do it.
Mm-hmm. And then we're good. All right, letter B now. We have cosecant of half x. And notice we're trying to find cosecant u du.
You put 1/2 x on
U equals 1/2 x, good. Du is 1/2. So if I'm going to rewrite our integral,
You need a 2.
we need a 2. Okay, and I just like showing this, especially in the notes here. When you're working on your homework, you can go a little bit quicker and skip a few of these steps. But we want to see everything here. So this is really 2 times the integral of cosecant u du.
Should there be a 1/2?
Okay, so 1/2 dx is du. All right, so now we'll use our integral of the basic trig function. So we have negative ln, so we're just going to say negative 2 ln in the absolute value of cosecant. And let's go ahead and substitute u in. Let's see, 1/2 x plus cotangent 1/2 x plus c.
Wait, what's it on your bearing? Sorry about that. Oh, yeah. That would help. So it's 2.
Okay. Let's move on. Example C.
This thing's nifty. Double pay. If I could do a lot more difficult to teach this class, I didn't have that.
So here we go. In this case, we see a fraction, and so we're going to think, possibly this is integration using natural logs. Notice we don't have just a single trig function here. And so in this case, we're going to switch things up a little bit, and we're going to let u equal the denominator. And then you'll see that du equals, Good. Negative 2 sine x dx. So we see this is almost in the form of u prime over u. So in this case, we don't use these yet, at least. Okay. So we want to make this u prime on top. So we're going to have to first pull out the 3. Okay, and we have to make sure it's a negative 2 sine x on top. So times by not 1/2, negative 1/2. Okay, and then on the bottom we still have 1 plus 2 cosine x dx. Now to solve this one, we have negative 3/2 times the integral of u prime over u. And this is what we were doing last time.
If we have all that complicated, like the 1 plus 2 cosine, can we break it apart and use, integrate 1 and then integrate 2 cosine next?
Okay, when you're working with a denominator, you can never break the denominator apart. That's got to stick together. Okay? So u prime over u is just natural log of the absolute value of u. And we'll just sub u back in.
It's hard to think about.
We didn't even use functions.
So we didn't even use the trig functions. Okay. So it's hard to say, you know, if there's a trig function, you use the integrals of trig functions. Well, not necessarily.
Well, then you kind of use trig function to find g.
Yes.
Yes.
Yeah, you're going to use the derivative of trig functions here. Yep. All right. And letter D here is another type of example you can see. Notice this isn't a straight trig function. What I'm really seeing here is a function squared.
So this is a problem.
So here, in this case, u is going to be our inside function of 1 plus secant x.
Would this be a problem, or would this still be a sine function? Or secant function?
For this one,
If you graph this, what will this look like? Would this still look like a secant function?
1 plus secant squared.
Squared? Would this still look like a secant function?
I don't know. You have to graph it. We can take a look at that in a second. So if this was u, what's du going to be? Secant x tangent x. You sure?
Oh, derivative.
Yeah. What's the derivative of secant?
It is secant.
Secant tan? Okay. Okay. So do we see du up here anywhere?
No.
No. Is there any way to get this?
No.
No. So there's no du, so we can't use the power rule here. So what we're going to do instead is actually square this function using FOIL.
Oh, fun stuff.
Okay? So remember, when you have a binomial squared, it's the square of the first term, which is just 1, plus 2 times both terms multiplied. So it's really just 2 times 1 times secant x. And then plus the second term squared, which is secant squared x.
Wait, 1
Secant.
Are we just factoring it out?
I foiled it out. Okay. What we did now is we created 3 separate functions. And we're going to integrate each one separately.
Oh, that's a cheater.
No, that's easy. Just leave it x.
Yeah, so it's easy. The integral of 1 dx plus the integral. Can I factor out the 2 there? Is that okay?
Wait, 1 dx? Oh, you're just freezing. Okay.
I'm just rewriting this here. Okay. So that's one of the tricks. When you have something squared, foil it out, you're going to get a trinomial. You integrate each individual
You can just do that
term.
without using substitution or anything.
Okay. So the integral of 1 dx is x. The integral of secant is, that's one of our basic ones, natural log of secant plus tan. So we have 2 ln secant x plus tan x. And then secant squared. What's that one? That is tangent x. And that's from last chapter, right? And remember, you can remember if you know the derivative of tangent is secant squared, the integral of secant squared has to be tangent, right? It goes back and forth. And then we can't forget, of course, plus c. And there we are. We're done. So that was integrals of trig functions. Any questions? What's the homework?
No, just
Or if there's
cannot
not,
ever break apart the denominator.
there's not much on my homework yesterday.
Right, you can never break apart the denominator of the function.
And can we times 3 using quiz then? No, we don't want to see quiz.
Page 330.
I'd like to see how to do number 5.
Number 29 through 36. And 49. No odd. It's all.